All right, so excuse me. So last time we were looking at arrays, and by this statement, um, int star array equals new int array size. What we are doing is declaring or creating a block of array that can have this many elements, array size number of elements, and that's something like this. And the each so this is like a consecutive block, each storing an integer, and this is the starting address, which is say 200, and I came up with this number. So in memory you will have a 32-bit memory address, and that will be the starting address, some address allocated by the operating system. So this array pointer, which is this name array in this code here, is the is storing the base address or the starting address. So the base address, starting address, basically is the address of the first index, which is index 0. So that's 200 in this example here. So that is stored in this array pointer, and using that base address we can access the elements of the array. So when I say that array pointer a in this figure here, a of 0 means basically that's the element at index 0 at address 200. So if I want to access the element at index 2, I can say array a of 2, the array pointer of 2. That means it will go to the array pointer, and its base address is 200. 200 plus that index 2 times 4. That 4 is the number of bytes allocated for an integer. So that is 208. So that's the address of the element at index 2. So using this, you can access any element in the array, what is called at constant time. Constant time means without going through a loop or anything, without going through the array sequentially from the beginning to the whatever the index we're looking for, we can right away access any element we want. So that is what is meant by constant time, or also noted as theta of one time, without going through all the elements like theta of n or theta of n squared, theta of one constant time. So similarly, if I want to access the element at index 9, if I say a of 9, that base address 200 plus 9 times 4 is 236, and that's where that element is. So you can right away access it instead of going through 200, 204, 208 and so on, and then accessing 236. So again, it's a theta of one time. Okay, so any question on this? So feel free to ask. So if you cannot hear it, please refresh your screen. There is some problem with that. So please refresh and make sure you can hear it. So feel free to ask if you have any questions. You can also use your microphone, but yeah, you should also click on the microphone if you cannot hear it. Will it always be 4? That's because if you're storing integers, an integer takes 4 bytes in memory, so that's why it is 4. If you're storing characters, a character is 1 byte in memory. If you're storing double real numbers, it is like 8 bytes. So if each of these elements is a real number, a double, so that will be then 200, then 208, 216, 224 and so on. So if you want to access any element in the array, it will be 200 plus whatever that index is times 8. Okay. All right, so let us continue. So last time we were here, and then so now I'm calling a function, say turn negative, and I want to turn all the elements in the array. Okay, so we saw also the random number generator, which I think everyone got it. So this is the code to generate the random numbers. So in order to generate random numbers, you should include these header files stdlib.h and time.h, and so you should initialize the random number generator using the srand function and pass a seed to the random number generator. So time of null is like gives you the current system time, so you can pass that as a seed to the random number generator. And once you do that, you can call the randoff function that will generate some random integers, and you want to generate integers in a certain range. So you get the max value as input from the user, and you do randoff mod max value. So whatever the random number that the rand function generates, you will get the remainder in the range from 0 to max value minus 1. So I said last time, if you divide anything say by 100, the remainder is going to be from 0 to 99. So in general, if you divide any value by some integer say n, the remainder is going to be from 0 to n minus 1. So if you divide anything by max value, the remainder is going to be from 0 to max value minus 1. And you're adding a 1 to whatever that remainder is. So 1 plus 0 to max value minus 1 will be now anything from 1 to max value. So that's the range of integers we want to generate. So those will be the range of integers in the array. So now what we want to do is we want to kind of turn all those elements to negative, but we don't want to do that on the same array itself. So let us see how this turn negative function does. So I have a figure here in the slide that that will explain this. So this is our array that we just created, and this array pointer is pointing to the base address 200. Okay, and I call this function turn negative and pass the base address array, which is the 200, and the array size, whatever the size of the array that we created. So let me go back. So it's an array of, I didn't specify a size, let us say it's 10 elements, in this case n elements. Okay, so we pass the whatever the array size is as the second argument. Now the turn negative function, I'm capturing these two parameters using these variable names. So I say int star capital A array, and then again a capital A array size. So that base address of 200 that we passed through this pointer variable name here, which is lowercase array, is now captured in this pointer variable name capital uppercase array. So there are two different pointer variables. So this is, you're capturing that within a function. So you should remember that's going to be a separate variable. So that's what I indicate by this array pointer variable, and its value is also 200. So remember, pointers always store address values. So this pointer stores whatever the value of array. So this is as if you're telling capital array equals array. So it gets that value, whatever you're passing from that function. So it's also 200. So using this pointer now within this function turn negative, you can access all the elements of that array that we created in the main function. And this array size stores the array size value that we pass. So if you're passing 10 as the value of array size here from the main function, that value will be stored now in array size. So now what I'm doing inside this function is I'm creating a new block of integers. So I'm creating, say, new int array size is going to create a new array of integers, and I am giving the base address name. So negative array is a pointer, is a new pointer that stores that base address of a new array that we created. So this is my new block of integers. So initially it doesn't have any of these values, it's just created in memory, and again 400 is some address I am coming up with. It could be any address in memory that the operating system will find out. So let us say it is 400. Again, this is a block of integers. When I say new int, that's a block of integers. So negative array is the name of the pointer that stores the base address, and its value is 400. So using this negative array pointer, I can access every element or any element of this array. So I'm going through a loop for int I equals 0, I less than array size. So that means I'm going through the loop, going through the array, and the original array is accessed within this function using this pointer variable capital A array. So when I say array of I can access any element at that specific index I, and whatever the value is, I'm multiplying that by -1. So we begin with I equals 0, so array of 0 is going to be 10. So 10 times -1 is -10, and that's the value I'm going to store in negative array of I. So negative array of I is now this block of memory, so I can access again the element at index I using negative array of I. And so in this case, if I is 0, that means the element at index 0 will be this -10 now. So okay. Then I equals 1, so array of 1 is 23 times -1 is -23, and that's the value that we stored in negative array is -23, and so on. So once you go through this loop, you come out of the loop and just say return negative array. So again, negative array is a pointer, and that will store the address, the base address of this block of memory. So that's 400. So that's the value you're returning from this turn negative function. So once you return from there, in the main function, you capture that. So turn negative is a function that you called from the main function, and you have turned everything to negative, and you have created a new block of memory that has all the negative values, and that address, base address, is captured now in a pointer variable called negarray. So so this is the pointer address value you are returning from the turn negative function, and you need to capture that value in a pointer variable of the same type. So you're returning int star. That's the data type you're returning, a pointer. You're returning the address, so you have to put star after the int. Int star means you're returning an address of a integer memory location. So you're returning the address, which is whatever the address there is, which is 400 in this example, and you're capturing that as a pointer to an integer. So that is negarray. So using this negarray, which will also store the value 400, because that's the value you're returning from the function. So it takes the value that you're returning, that is 400. So in the main function, so you can access this. Yes.
I don't understand why it's on 400.
Again, the 400 is the number I came up with. It depends on what the operating system may find out in memory that's allocated. Okay, so the addresses I'm coming up with is just to illustrate the idea. Is what I mean. So
Okay.
yeah. So the scope of, so you should understand the scope of this variable. So this array pointer is visible in the main. Yes. Go ahead. So this array with the lowercase is visible in the main function. This capital array pointer is visible in the turn negative function. Similarly, this negative array pointer variable is visible in the turn negative function, and this negarray is visible only in the main function. So you should have seen all these things in the earlier programming classes too, the visibility of the variables. So whatever you declare inside a function is visible only within the function. So the negarray is something I'm creating in the main memory to capture the return address, so that is visible in the main function. So using that negarray, you can access now the elements that have the negative values. So basically, we have not changed the contents of the original array that we created. We have created a new block of integers that store the negative values, right? And then you can go through a loop to print those negative values. Now, once you're done with everything, as a good programming practice, you should delete all the memory block of integers that we created. So this is the syntax to delete. Delete off is a syntax to delete a dynamic block of memory that we created, and the array pointer variable name is passed to that. So with this, you are basically clearing off whatever the block of integers that we created. So when I say this delete empty square bracket array, So basically this block of integers that we created will be cleared off. So all this will be cleared, so some other program can use this memory space. Similarly, when I say delete of neg array, because all these things are done in the main function now, so you can access those memory block of addresses only using those corresponding pointer variable names. So I can say delete of neg array means this block of integers will be cleared off. Okay, and then just to pass, if you print anything or anything, something to capture them as a screenshot, you say system pause. So the output will just stay on the screen and you can capture as a screenshot if you have submitted as part of a programming project or anything. So that's why I use system pause. Right? Any question on any of this? So this is something that you have to really understand to do the other programming things in this course, how to use arrays. Okay, so let us now go through one more example with arrays and then we'll go to the next module. Okay, so object-oriented programming with arrays. So let us see a class called packet which I just created, and it has two member variables, an integer ID and a double data, and you declare these as private. So these things which you have seen in 119 or even in 118. Okay, now I need to create the constructors and the member functions for this class. So the constructor, you can have different formats. So this is a no argument constructor with the class name packet, and I don't have any code in this, so it doesn't do anything. And this is another constructor that we can create for this class, and it takes two parameters, the ID and data. So since I have ID and data like this, I am having them like this as a member variable as the parameter name, so they're different. Now I have two member functions, set ID and set data, to which I pass this ID and data. So the set ID basically sets this ID member variable equals this parameter ID. So you can do like that, and data equals this data. I have get ID, get data functions that return the ID and data value, and this should be straightforward. You should have seen this in object-oriented programming, right? Alright, so now what we are going to see is what are different ways we can create objects of this type class packet, and using both pointers as well as without using pointers. So this is a very straightforward way of creating an object. This is the class name packet, and then I am specifying a name of an object. So packet1 is the name I came up with. You could have any name for the object, say my packet or anything. And to that object name, so when I say that, what is internally going on is, so let me create a new slide. So when I do that, so a block of memory is allocated and its name is packet1. So it's referred using this name packet1. So packet1 is basically referring to this memory location, and that's the object, that's the name of the object, and that's this object that we created, and the ID and data have not been yet initialized. So when with this you're calling the no argument constructor. So the no argument constructor doesn't do anything, so the ID and data, the member variables, are not initialized yet. So I'm calling the set ID and set data functions on that object. So I'm calling packet1 dot. You have to use the dot operator because this is an object. You have to use the dot operator and call the member function. So packet1 dot set ID, and you pass whatever the ID you want to set. So the set ID function takes up an integer argument, so you have to pass an integer value. The set data takes up a double, so you can pass a double. I can say 10 or 10.1 or whatever the data that you want to pass. Okay. So then they will be initialized. So this ID, this is how it is. ID is 1 and then data is set to whatever the data you're passing. So as I type, they convert to uppercase, but this is the member variable names, ID and data. So if I want to now print the values of these member variables, again that object name packet1 dot get ID and packet1 dot get data will return you the return the ID and data, and you can return it. Okay. Now this is another way you can create an object of this class packet using other constructor. So we create an object using the first constructor. Now we can create an object using the second constructor that takes up the ID and data arguments right away. So packet, again the class name, and packet2. So this is a different object that takes up the ID and data as the arguments using the constructors. So that means in memory I'm creating a different object. I'm just copying and pasting it to. So this is somewhere else in memory. Packet2 is created and its ID is 2 and data is 20. And you can again use the get function to print their values. Now this is the important thing. Now I want to create a pointer to this packet2 object that we created. So we already created packet2, it's somewhere in memory. Okay. So you should know when you put an ampersand before a variable name. So in this case the variable is the packet object. So when you put an ampersand before the variable name, it returns you the address of that location where that variable is stored. So I have indicated that here. So packet2, let us say it's stored in address 200. So that's the address where that packet object packet2 was created or stored in memory. So now you can store that address 200 in a separate variable. Again, this is an address, so you have to use a pointer. Now this address 200 has what data type? It has a packet data type. So that's the data type of this element that you're storing in this address. So that is why you have to say packet star. So if it was storing an integer, you would have said int star. Whereas this memory address is storing a packet type. So that's why you have to say packet star, and then this is the name of the pointer variable you want to use. So you could name it anything you want. So I'm just naming it packet ptr. So that is how it is stored. So packet ptr, of course this is a variable, so it will be somewhere at some address, say 1000 or whatever the address it is allocated for. We are not bothered about that address where the pointer is stored. We are bothered about what value the pointer is storing. So the pointer variable will also be created somewhere in memory. So when I say at, that means where it is. That's the and whatever the value I'm passing, I'm writing after the at, it means at that address. So it will be stored somewhere in memory at some address, but we are not going to be really bothered about that address. What we really need to worry about is what value it is storing, the value, and it is storing the value of that packet object. Yes, what question it is?
So with packets, does it, like the memory address, it goes by 100?
No. Again, don't worry about the exact values I'm coming up for the addresses. Just to illustrate the idea, in memory it will be like a 32-bit quantity. So the actual address will be some in hexadecimals like 2A, 4B, 3C, and something like that. So if I put some complex address like that, it will be tough to visualize things. That's why I put integer addresses like 100, 200, and so on. Is that clear?
Okay. Yeah, I understand.
Yeah. So the packet pointer is storing the address of this packet 2 object that we created at address 200. So using now this packet pointer, we can access this object. So we have two handles now to this packet that we created. Using packet 2, which is the object name, we can access this packet object, and this packet pointer is now a pointer to the object. We can access it. But the difference in how we can access is this. If you are accessing using the object name, which is packet2, you have to use the dot operator like packet2 dot get id or get data, or you can even change the data. Initially I set it to 20. If I want to change it to something else, I can say like this: packet2 dot set data to something else, say 30. I can do that. Now if I want to access that packet using the packet pointer that we created, the operator we have to use is the arrow operator. So that's it's like set. Okay, so the operator we have to use is the arrow operator. So if you have not yet if you do not know the difference, this is the time to know the difference. If you access a packet, an object, basically using an object pointer, then you have to use the arrow operator. If you access an object using the object name itself, you have to use the dot operator. That's the difference. Okay, so there's nothing to get confused. If you're accessing using the object name itself or the object itself, then you have to use the dot operator. If you're accessing the object using the pointer to the object, then you have to use the arrow operator. So packet pointer is now a pointer to the packet object, packet2. So you have to use packet pointer, arrow set data, and change its data to whatever value you want. So now if I want to call the get id function and get data function to print the contents of that packet using the packet pointer, I have to do it like this: packet pointer arrow get id you're calling the get id function in that for that packet object, and get data for that packet object. So whatever the values you're storing for id and data, you're trying to print them using the packet pointer. So packet pointer is a pointer to that object, so you have to use the arrow. So think about like this: the arrow is pointing to the object, so you have to use the arrow operator, and this is there itself, the object name itself. So packet2 dot get id or packet2 dot get data will return the id and data. Okay, so is there any question on this? That's a very fundamental thing. You have to know how to access an object using the dot operator and the star operator, right? Okay, so let us continue. So now what I'm doing is I'm creating a new or another new packet. So this is going to show you how to create an object, a packet object, using the new operator. So new is like creating a new array. So now, but I'm just creating an object. So new is a built-in name. Then packet is the class name. So when I say packet of, I am basically calling the no argument constructor for the packet class. So it doesn't set the values for id and data. So I'm just creating that block with this id should be lowercase, because so when I move the cursor it is becoming uppercase. Okay, so this is id and data. Now I've just created it, so it was going to store the junk values. Okay, because I have not set up the value set, so that's why I said at the time of creation. And let us assume again, as for ease, let us say it's stored at address 300. It could be anywhere in memory, and that's the address you have to represent here. So let us assume it is 300. Now that's what the right hand side doing. New packet basically creates a new block, a new memory block to store a packet, and the values of the memory variables are not yet set up, so there will be some junk values. And that address, so a new operator always return the address of where that block is created. So here I am creating just one packet object at address 300, and that address is now captured in a pointer. I say pktptr, packet pointer, and it stores that address 300. So this is how you need to use that. So again, you're storing in a pointer to an object. So packet is the class name, so you have to say packet star, and then pktptr is storing the address of that object. So now you can call the set id and set data functions to set the values. Remember, you have not yet set them yet. So how to do that? Using the packet pointer, whatever that pointer name, arrow set id, and pass the id value. Then packet pointer arrow set data and pass that value, and then you can call the get ID and get data functions and print the values too. Again, you have to use the arrow operator because you are accessing that using a pointer to a packet. Okay, any question on this? Okay, now what I'm doing is I'm going to store. So we are currently something without this, right? So we have set up the values, ID and data. So now what I'm going to do is I'm going to use another pointer called as copy packet pointer that will have this value 300. So this is also a copy packet pointer is a variable of type packet star, means it's a pointer to a packet object. So this is how you have to declare it, packet star copy packet ptr. So copy packet ptr is a pointer variable for the class packet. So I say packet, the class name star, to indicate that's a pointer of type packet. And so I can, again, it stores the address of a packet object, right? So I am assigning it the value of this pkt ptr that also stores an address of a packet object. So pkt ptr is 300 and I'm assigning that value to copy packet ptr. So copy packet ptr now also has a value 300. So that's an address value. So using this copy packet ptr, I can also access this object. So you can say copy packet ptr arrow set id and change its id, or copy packet ptr arrow get data and get the data. So you have two handles now to this packet object. You can access that using this pkt ptr or copy packet ptr. So typically we go through this strategy to do something like this. Now I created first an object and had this pkt ptr as a pointer to that object, and now I have copy packet ptr that also has the address of that object. Now I will reassign this packet ptr to point to some other address like this. So I am creating now a fourth packet using this constructor that takes the ID and data. So packet 4 and 40, and I use a new operator, and that returns the address of where that new object of 4 and 40 data type is stored. So it's, let us say it's created address 400, and that's what the new function is returning, and packet ptr is assigned that value. So when I do that, packet ptr now has 400. So using that packet ptr, if you say packet ptr arrow get id, you are going to print this value 4 and get data will return 40, not 3 and 30. So packet ptr is now pointing to this address. So how can we access now the third object that we created? We have a handle still to it, that's a copy packet ptr. So that's why I created a copy of this pointer value and stored that in another pointer variable of type packet that stores the address 300. So using that pointer, packet pointer, we can still access that object that we created. Okay. Now if that's what you want to do, you can then delete all the pointers we created. So you can say delete packet ptr, so that clears off this memory. You can also say delete copy packet ptr, that will delete off this memory. You can also delete all the other pointers you want to create, you created earlier. Okay, so that as a good programming practice. So I'm just illustrating here this one thing. You can write similar delete statements here below this to delete all the other packet objects that you created dynamically in memory. So anything that you create dynamically in memory using the new operator, as a good programming practice, you should delete the memory block. Okay, so anything before you see one more thing, that's with arrays of objects. Any question? Alright, so let us finish off this program with the last thing here. So I want to create now, let me stop this video for a minute, let me save this, it's getting big.